Good morning friends, I am Gunipati Vandana. Today I am explaining the code for chart with PDF using RAG pipeline. Coming to the code, let's break the code into the different chunks. First, the cell, install sentence transformers. This line is using the pip command, which is the package installer for Python. Essentially, it's like saying Python, I need these tools to do my work. Please get them for me. Here's what each package does. Sentence transformers. This package provides pre-trained models to generate embeddings. Embeddings are a way to represent text as numerical vectors that capture the meaning and relationships between words. The model used in the code is designed to create embeddings specifically for semantic similarity tasks, which means it aims to identify how similar different pieces of text are in terms of their meaning. FAISS CPU stands for Facebook AI Similarity Search. This library is used for efficient similarity search and clustering of dense vectors, like the embeddings created by sentence transformers. Using FAISS CPU means it's optimized to run on your computer CPU. The long chain is a framework designed for developing applications powered by large language models, that is defined as LLMs. It can be used to build chatbots, question answering systems, text summarizers, and more. The package is used to make HTTP requests in case it is used to download the PDF file if the file provided path is URL. FIDS, also known as PyMUPDF, is a Python library that provides bindings to the MUPDF library. It's used to work with PDF documents, enabling text extraction and other PDF manipulation tasks. NumPy is a fundamental package for numerical computing in Python. It's used for working with arrays and matrices of numbers and is a building block for many other scientific and data analysis libraries. So these are the libraries required for our code to execute and compile. So the required libraries are installed here. These are downloaded libraries. And moving to the next cell, we are installing the force reinstall PyMUPDF. As we said before, the PyMUPDF is used to build chatbots, question answering systems, and text summarizers, and more. And coming to this library is also installed by collecting PyMUPDF, and now it is downloaded, and the collected packages are also installed. Coming to the code, importing the libraries and packages required. FAISS, NumPy, sentence transformers, these are installed previously, and now we are importing those all. Now we are initializing the sentence transformer model. We are defining the model and the function to extract text from a PDF. This function accepts a PDF path whether it is local or URL. If it's a URL, download the PDF using requests. Process it as a byte stream. If it is local, opens the PDF with PyMUPDF, extract text from all the pages and returns it as a string. If the PDF path starts with HTTP, the PDF is fetched via HTTP, converted to a byte stream and processed. For local files, it directly reads the PDF using FIDS. It is also a library which was installed previously. Now function to chunk text into smaller pieces for embeddings. Now we are dividing the large text into smaller pieces, which is a divide and conquer method. In this method, we call the small text like functions are known as chunks. Splits the extracted text into chunks of manageable size, default 500 words. Every chunk needs to be 500 words with minimum. This ensures embeddings are computed for smaller sections, improving relevance and efficiency. Now, generates dense vector embeddings for the text chunks using the system transformer model. Function to create embeddings for chunks. The function is used to create the embedding of chunks. This function is used to generate dense vector embeddings for the text chunks using the sentence transformer model, and caches embeddings in a pickle file, which is embeddings.pk1 is the extension for faster reuse. It is used for reusing of code, which is reliable, scalable, and maintainable, and most likely it is reusable. Now these embeddings of chunks are stored in FAISS. Embeddings are stored in FASS index for similarity search. This is used for similarity search, which the text is similarity. Then index flat L2 is created for L2. It is Euclidean distance similarity. Embeddings are converted to a float 32 numpy array and added to the index. Function to perform similarity search on embeddings. This cell is used to encode the user query to an embedding. Searches the FASS index for the top k default 3 most similarity embeddings. Returns the corresponding text chunks. The similarity is finded and the text is again divided into chunks based on the similarity factor. Fetch the most relevant chunks. The most relevant chunks which are repeated more than twice, those are fetched and again divided into smaller chunks, and the more similarity factor are reduced. Function to generate a response. This step is used to simplify the lang chain. Here this cell is used to combine the relevant chunks into a context, formats the response by including the user's query and the retrieved context. Here we can get the response of the query. This purpose is combines the most relevant text chunks into a context and formulates a response. The user's query is the input and the response is the output. The main pipeline for function. Now we are defining the run pipeline. This includes some steps. Step 1 is extract and check text. The text is defined and extracting, and the chunks are formed based on the text. And step 2 is create and store embeddings. Now the embeddings are defined based on the create embeddings and the chunks. Now we are giving the index to the chunks based on the store embeddings in FASS. FASS is the indexed platform. Step 3 is retrieve relevant chunks from the query. The query is the user's input and the retrieval chunks relevant to the query is the output. And finally, the generate response. As we said before, the query is the user's input and the output was to give from the server to the user is the generate response. Now we are returning the response. This is the final code and running the pipeline. We are using the pipeline of RAG. We are using the retrieval augmented generation is the main pipeline in this code. Now we are pathing to the PDF file you want to process. That the user want to process the path file that is processing. From this path, the file is extracted. The file is imported to the code, which is the user's work. And the query you want to ask based on the context of the PDF. This is also the user's input. The user is first uploading the PDF file as the user's requirement, and the user is supposed to ask the query based on the requirement of the user from the PDF. Here the user is asked to query and run the pipeline by using the response. Now we are printing the response. Here is the response based on the provided context. Here is the response to the user's query. The context tables with examples from history, economics, education, psychology. This is the final output which is required the user. This content is from PDF and we chat the PDF by using RAG pipeline. Finally, the outcomes are this pipeline can be used for extracting insights from large PDF documents, building question answering systems for reports, research papers or manuals, automating document analysis tasks for various industries. These are the outputs from the task given chat with PDF using RAG pipeline. Thank you.